In today's video, I am going to show you how to perform paired end read framing and filtering using the tool Cutadapt. So if you want to read more about this tool, then you can visit this page. The download link to this page is in the description box. So when we are here, there's a brief description of Cutadapt, which you can read, and you can also click on the user guide section to get a documentation for Cutadapt. Okay, it has lots of options that you can use. For this, we are going to perform a very simple trimming and filtering exercise. So I'm going to share this slide with you. This is what we are going to do. So we are going to run Cutadapt, and then we are going to specify these options. And by the way, I'll use an example data, so don't worry, I'll show you where to get the example data. I'll also show you how to install Cutadapt. So just follow this explanation here. So we'll call Cutadapt, and then we specify -20. So -0 here is used to specify a quality cutoff value. So we'll use 20. So that means that we are going to frame the low quality end from the reach, and we are using the cutoff value of 20. Now with Cutadapt, you can specify two quality cutoff values, but since we are using one, that means that we are going to frame the 3' ends of both reads. We are going to use paired end reads, by the way. And then -m here is used for the minimum length, right? So this means that we are going to discard reads that have lengths less than the threshold here, -m. And then we're also going to use --pair filter equals any. So this particular option here indicates that if one read is removed, the other should also be removed, because we are going to use paired end reads. So if one is removed, the other one should be removed. That's what this means. And then we have output forward, output reverse. So these are used to specify the outputs. We are dealing with paired end reads, so we need to also get outputs for both reads. And then these are the inputs. So we have read 1, read 2. So it should be specified in this order. So this is basically what we are going to do. Now, for this tutorial, this is what we will do. We are going to first install Cutadapt. So to install, you can use conda or mamba or micromamba to install. There are other approaches to install, but the quickest and easiest way is to use any of these to install. And I have tutorials that show how to install any of these, all these. All right. So there are tutorials to show you how to install conda, mamba, and micromamba. So check the description where you find links to those videos. So those videos will help you to set up your PC. So that's about it for the intro. So let's get started. So let's get back to the Cutadapt page, which is here. So I'll do this. Let's just go over. So there's the user documentation page. So just make sure to read it. Now let's get to this. I have some pages that I can also use to read more about Cutadapt and its usage. I found this one particularly interesting, so you can just read this one. There's a section for trimming. There are lots of tutorials, by the way, for Cutadapt, so you can start with this one and then search for others as well. Okay, now for this we are going to use an example data from this tutorial here. This tutorial here I always come back to. So there's a reference-based RNA Seq data analysis. So they have some example FASTQ reads, or let's say FASTQ data sets that were used. And so I'm going to use this data to explain or to show how to trim and then filter with using Cutadapt. So the link to this page is in the description box. And by the way, this tutorial here, I've covered them in bits. So the mapping side, I've covered it. The read calibration side, I've covered it. The differential equation analysis side, I've covered it. And also the functional arrangement analysis side, I've also covered that as well. So just tell the customer you'll find links to videos relating to this particular one here. So that's it. The link to all those videos are in the description, so I repeat. All right. So let's get down to the quality control section. That's where we find the example data. Yeah, I mean, that's where we find the instruction, by the way, but the example data is also around the same place. So we are here. So when we are here, just check for data upload, this one here. So click it, then you find the links here. Now the data, we have the complete data set and we also have the subsampled one. That's what I'm going to use because those ones are smaller. I have them here like this. That's what I'm going to use. So if you're using your ordinary piece, then this one will be fine. Okay. So let me just also enlarge this. It should be better now. All right. So these are the examples we are going to. So we have two samples here. These are paired and weight. We use just the first sample. That's what we are going to use. Okay. That's it. Now, before we download this, I want us to install Cutadapt. So I'll move to a terminal that we can start the exercise proper. So let's check it out. Let's move to a terminal. And of course, there's a bioinformatics tutorial. So obviously you need a Unix-like operating system. I'm using Linux, Ubuntu to be specific. Okay. So I'm first going to install Cutadapt. Now the instructions for install Cutadapt can be found here. I think we should look at that because there are different approaches for installing. On the Cutadapt page, just click on installation and you have the various options. So you can install with conda, etc. All right. So you have to use the one that you are comfortable with. But we are using conda, and that's what we are going to do here. So we will create the environment and we are going to install Cutadapt. It's very, very simple and straightforward. So I repeat, conda or mamba or micromamba, any of them can be used. All right. But preferably you can use mamba or micromamba because those ones are faster when it comes to installation. But I will use conda because it's a small file size. So I'll move back to the terminal. Okay. So I'm now going to install Cutadapt using conda. So I'll first create an environment and then I will install Cutadapt in that environment. So I'm going to say conda create and I'll say -n and I'll indicate the environment name. So I'll use QC like this. And then I'll also specify the channel. So I'll say -c bioconda. You can also add -c conda forge. You can also add -c defaults, all right, just to be safe, all right? So that's how we are going to do it. We are going to specify the tool, in this case, Cutadapt, like this, and we are going to execute this command. So if you don't have conda and you have mamba, then you have to come to this side and then change to mamba. Or if you have micromamba, then you just have to use micromamba like this. So any of these should work for you. But I'll use conda because that is what I have installed on my system now. So this is going to be the final command. So let's execute this command. And take note that if you're using conda, then the time it takes to install or to resolve the environment will be, it can take some time, that's what I'll say, but you'll be fine. So let's proceed. Okay. So now I'm going to type Y to confirm, then I will hit the enter button. So conda will download all the necessary packages, install and configure them for me. So I'll have to wait for everything to get done. Okay. Cutadapt has been installed. So if everything is okay, then you will see this message coming up. So there's instructions for activating and deactivating the environment. I repeat, there are instructions for activating and deactivating the environment. So if you want to use Cutadapt, you need to first activate the environment. So we have to do this. So let's just do that. Then let's clear the screen and then let's activate the environment. So I'm going to say conda activate QC. This is the name of the environment I used. All right, that has been done. So once it is done, you can just test Cutadapt. So you can say Cutadapt, and then you get something like this coming up. Of course, there's an error message here because we didn't specify any inputs and then any options. So this is fine. So that's what we need to know. So let's proceed. I'll clear the screen first and I'll proceed. Okay. So now I have installed Cutadapt, and so what I need to do is to get the example data set that I'll use for this exercise. We are going to perform read trimming and filtering. All right. So let's do it. First of all, let's create a directory that we work in, a working directory. I always do that so that I can organize my files. So I'll say make that, and then you can give it any name of your choice. That's also fine. I can just say Cutadapt tutorial. All right, like this, or just use any name. That's what I'll say. So this the name of the directory. I'll also do this. I can read this Cutadapt underscore tutorial by this to get the name. So this is the name I am going to use. All right. So I'll create a directory and then I'll seed into it. So that'll be Cutadapt tutorial. All right. So I have seed into. So now I'm going to download the example data. So I'll go back to Galaxy. Let's get back here. And by the way, the link to this page is in the description box. So when you are here, just make sure you are in this section. For those who are beginners and who are confused, just come to the main page, scroll down a bit, and then come to this section, agenda, and then click on data upload. So to send you to that side. All right. So now we are going to download the example data, which is here. So this one is these are the main files, the complete files, and we have the smaller ones. Let's see, which are here, the subsample one. That's what we are going to use. So we are going to download a single sample. So this and then this. We are dealing with paired and read. So we have the forward and reverse. So I'll start with the first one, the forward. There's it. So I'll just copy the link. I only want the link because I'm going to download on a terminal, but you can also download using your browser. That's fine. But if you are working on a remote system, a Linux cluster somewhere, which you don't have access to internet browser and stuff, you have to use the link. So I'm going to copy the link and I'm going to move to the terminal. And then I'll use wget. I'll say wget and I'll paste the link there and I'll execute this command. So this will download a file for me. Okay, read one has been downloaded. So let's take a look at the reverse reads. So let's come back here. So let's copy the second one. Then let's move to the terminal and then let's say wget and then let's paste it there. So let's execute this command. Okay, both files have been downloaded. So let's clear the screen. Let's do an ls and we are going to find the file there. So these are the files. We are dealing with FASTQ files. All right. Now we need to organize the files. So what I want us to do is to create another directory and then move these files in that directory. These are raw reads. So I'll say make the raw underscore reads and I'll move the files there. Now I have just two files. So these files all begin with GSM. So I'm going to say mv GSM star. Yes, GSM. Yeah, so GSM. And I'll say star. So this means that I'm going to move all files that begin with GSM. Then have other characters after this, after these three letters. So GSM star. So I'm going to do this and I'll say raw reads and I'll move them there. So if I do an ls, I see my raw reads. If I ls into it, that's ls raw reads, I'll see my files. All right. So this is how we begin the process. So now we have organized the files. Okay, so we can proceed. Okay, so now we are going to perform our read trimming and filtering. So let's do this. Let's get back to the slide I showed earlier on. All right, let's go back to this one. So this is the syntax I gave. All right. So in this tutorial, this is the actual command we will use. This syntax was to help you get an overview of Cutadapt. So this is the actual command we are going to use. All right. So I've also bolded some letters here. So these ones are going to be specified. So in the syntax, this is the overview. So everything here except this side has changed. So here, if you're going to specify the output forward and output reverse, then you need to add -o and then -p. All right, that is all that you need to do here. So -o, you have to specify it and then indicate the name for the output forward reads. And then -p, you will use it to indicate the name for the output reverse reads. Okay, so that's what you need to do. Now, let's do this. So with the reads, let's get back. I'll show you something here. You know, with the reads, some of the reads will have names 1, 2, some will have underscore I1, R2. So there will definitely be something to differentiate between the forward and reverse reads. So that one, you always have to pay attention to that, because if you are also going to deal with multiple samples, or if you're going to handle multiple samples or multiple files, you need to pay attention to the naming convention that you use. So I thought I'll bring this up for you. All right, so let's do this. Now, since we are going to generate outputs, it's also important that we create a directory to store the outputs. So I'll say make the string reads. I'll do an ls just to see that directory. At the moment it's empty. So we are going to do this. We are going to trim our reads, and then the output, the trim reads, we are going to save them here. These are the raw reads, right? So now you can see I have a directory for raw reads. We have a directory for trim reads. So this makes it very simple and easy. Okay, so it's part of organizing your files. Okay, now if we take a look at the names for the files, we have read 1, read 2. The names are long, all right? So sometimes it's also advisable that you find a way to make your work organized and look better. And so what we're going to do is to create variables and then define our input files. And we're also going to create variables to define our output files. So I'll do this. I'll start by doing this. I'll say read 1 equals, and I'll specify where read 1 can be found. So read 1 can be found in what? Raw reads, yeah, it's raw reads. So raw reads / gsm _1 subsample.first sanga. Then read 2 is equals to what? Raw reads, the same number, this time 2. All right, that is it. These files, they should exist and we know where they are. Now for the output files, we are also going to define them because the names can be long. Okay, so we will just try to give them some shortened versions. So with the output files, we will start with the void. So we will say output void equals, and I'll say trimmed reads / gsm 461177. That's the sample name. So you have gsm 461177, but you can also use any of it, so that's fine. You just have to be consistent. And then I'll do this. I'll say underscore trimmed _1 dot fastq sanga. Right, this is going to be the name. So I've maintained a sample name, but I've added this extra information so that anyone who sees the files knows that these are trimmed reads. It's always important to add some description to your files. It helps, all right, especially if you have new people coming to take a look at the files or outputs. All right, so this is going to be output void, and then output reverse equals trimmed _reads / gsm 461177 underscore trimmed underscore 2 dot Fascale Sanger. Right, so this is going to be the output reverse. So now we have everything we need. So we can now call Cutadapt and perform the trimming. So this is going to be the command. I've showed it. I'll show it again. This is going to be the command. We'll call Cutadapt -Q20. That's the quality cutoff. -M minimum length. We specify this, then the output, and then we finally indicate the read 1, read 2. All right. So we are going to do that here. Of course, here you add something to these ones because these are variables. So I'll show you how that is done in Linux. Okay. So we are going to call Cutadapt now. So that's what we do. We will say Cutadapt -Q20 -M20 -pair filter equals any. You say -O $output forward -P $output reverse, and we say $read1 $read2. So this is going to be the final command. So why am I using these options? I'm using this option because I'm trying to reproduce this gallery tutorial. Let's just go back. The gallery tutorial I earlier on showed. All right, so this side here. So they have the trimming section, quality control, and then they use Cutadapt, which is here. So I'm basically following what was specified here. All right, so we are dealing with paired and reads, and then for the filtering, they use a minimum length of 20, and then the read modification options, that's quality. They also use 20. That's what I'm using. All right, so that's why I'm using those cutoffs just to reproduce what was indicated here. Right, so take it like that. I'm also going to make another tutorial where I show how to perform the read trimming and filtering on Galaxy. So for those who are also following my Galaxy tutorials, just watch out for that video, because some of you may still be beginners when it comes to programming, bash scripting. So if you also know how to use Galaxy to perform some of these tasks, then it's also very, very helpful to you. So just stay tuned for that video as well. All right, so that's about it. So we'll get back to our terminal, and then we are going to execute this command. Okay, so this is the final command. So let's execute it now. Let's just do it now. Okay, so now everything has been done. So let's wait for everything to get done for us. Okay, Cutadapt has completed its work. Now let me say that before you even perform the read trimming and filtering, it's important to perform the quality control to assess the quality, get some reports. Okay, and then after that, you will perform your read trimming and filtering, and also perform the quality control again, and then compare. It's always important to do that. Sometimes you will perform your read trimming and filtering, and then you will realize that there isn't much difference. All right, or you could also see that the trimming and filtering has improved the quality. So it's always important to perform the quality control first before you do that. I should have made mention of that before starting this video, but it's important you get to know that. All right. For quality control tutorials using FastQC, I've covered some tutorials on that, so you can check the description box. There are links to videos that show you how to perform quality control using FastQC. All right. So just make sure to check the description box for those videos. Okay. So trimming has been done. Filtering has also been done. So you have a brief report here to tell you what has been done, and then you can always follow up or do some additional checks or perform some additional analysis as well. Okay, so that's what we have. So let's look at this. Now let's take a look at the output. We will come back to this later on. Or actually, let's even do this. Let me just take you through this one again. Now with the summary here, all right, by default, Cutadapt displays it on the screen, but it's possible to save it to an output file. All right, Now, let's just say we've cleared the screen. All right. The report is gone, but sometimes you may need a report for some additional analysis, or you may need a report for verification purposes. So it's possible to save this report to an output file. And so if you want to do that, you can just recall the command. Let's recall it again. Space, and you can just add this redirection and say maybe report.txt. All right, like this. Now I think I'll just reduce the font size for us to see. It's supposed to be on the same line. Okay, so maybe some of you may be confused. I'll just reduce the font size so that we see it's proper. Let's say I'll just reduce it a bit, one more, so that we see it here. Yeah, okay, so it should be something like this. So we have your Cutadapt command, and then you bring this symbol redirection, and then you indicate the output file. So the output file, you can put it in the trim directory or anywhere, but at the moment we are going to put it in our current working directory. All right, so we can execute it like this. All right, so if you execute it, then what is going to happen is that the output will be saved in that file for you. So let's wait for everything to get done for us. Okay, it has been done. All right, so if you do an ls, you are going to find this report.txt, and say cut for the tst, and then you see it there. All right, it's also possible to let Cutadapt run in the background without you having to see it. Let's clear the screen. Okay, you can also do this, then add the end symbol to it. So let me just add it here. Okay, like this. That is this symbol here to end it, this end symbol here. So if you execute the command, then what's going to happen is that some output may be suppressed. Okay, but in this case, nothing was suppressed. We still have everything being run for us, but it's possible that some output can be suppressed if you use the end, and then that's it. But basically, this one is what you need. I mean, for beginners, I'll encourage you to just focus on just this one here, and then forget about this one here. All right, so that's how it's done. So we will do this. Once this is done, we are going to rerun Cutadapt one more time. Okay, because for beginners, you need to do a lot of practice to be able to get used to it. So we will do it again, and then we can examine the outputs. Okay, so this one is done. So I'll just hit the enter, and then I'll see something like this. That's done. So ideally, what you want to do is to just use this one. Okay, this one is very, very simple. So just follow just this one here. Okay, this is simple for beginners and it's easy. So this one, once you do it, then Cutadapt will work, display what it needs to display, and some of them will be suppressed, but those that are suppressed will be placed in this file here, the report.txt. So once Cutadapt is done, like in this case, you can just do an ls to take a look at the file which is here, and you can do a cut. All right, I will enlarge the text again for us to see. Now we are done with that, so I'll just send it back to the 23. I think that's better. Yeah. Okay, so I'll see it like this. Okay, so I'll just clear the screen. I'll do an ls to see the file, which is here. This is the summary file. So I'll do a cut to just look at it. Okay, so that's how it's done. So let's clear the screen again, and then we can proceed. Now, please take note that this report here, okay, the Cutadapt report, it's possible to aggregate them. So you can use tools like MultiQC, right, which is here, to aggregate the Cutadapt report. But that's something I'm going to cover in another tutorial. Okay, for now we are dealing with just a single sample, so I'll do that later on. So now we have just been looking at the report, but we can also look at the outputs. So if you do an ls into trimmed reads, you are going to find your output files there. All right. So once you have this, which are the outputs, you can perform a quality control again and compare what you have to the raw reads, and then look at the one which has a higher quality, and then you can use that for downstream analysis. All right, so that's how we do it. Now we are dealing with RNA-seq data, and so for RNA-seq, after performing quality control, performing retrimming and filtering, what you want to do is to map your reads to a reference sequence. So if you want to learn how to do that using tools like STAR, then I encourage you to check this video right here.